section 2.3 is on finding the domain in the range. On number 1, so you see it's giving you a graph with several different points on it. What this first part of the problem says is what is when f of -3. Find the function value or the value when x is -3, because this is like saying f of x. So this is your x coordinate. So go over to your x where it's -3. So x is -3 right here. Well, let's see what that corresponds to. If I travel up, this is the point that it corresponds to, this point right here. So you're just going to trace it over to see what the value is, which is the y coordinate of this point. So again, find this x value, so -3. So there's my -3x. Come up to the graph, touch the point, and see what it lines up with. Well, what does it line up with on the y-axis? It lines up to the y being 3. Now, the domain is talking about what are all the x values of this particular graph. So if I'm looking at each of these individual points, since they are just individual points and not a continuous graph, then the domain is going to simply be the x coordinates of all of those points that you see on the graph. So let's start over here at the very far left end of the graph to get the smallest number in the domain. So again, this one lines up, its x value would be that -5. This one's x value, its x coordinate is -4. This one's x coordinate is that -3. This one's x coordinate is -2. This one's x coordinate is -1. This one's x coordinate is 0. And this one's x coordinate is +1. So it's going to still just continue on to -1, 0, and 1 for that last one. So you will just enter these numbers in for the domain of that graph. Now, this part says find any x values for which, now we haven't talked about this before, but f of x and y are interchangeable names. F of x means the same thing as y. So this actually says where y equals 3. So I need to go and find, here's my y coordinate being 3. Well, if I'm trying to find any point that corresponds with this, I actually go and I see 2 points that are corresponding with the y value being 3. So do you see how each of those 2 points right there have a y value of 3 because they are both up 3. So let's see, this one's x coordinate would be -3. And the other one whose y value is 3 is this one, and its x value or x coordinate would be -1. Now, the last part of this problem says find the range. The range is what? So the range is talking about the y coordinates of these points. So let's see. This one is lined up for the y value is 2. These both are lined up for the y value being 3. These are lined up with the y value being 4. And these are lined up with the y value being 5. So the range would be 2, 3, 4, and 5. All right, number 2. The graph here is a continuous graph. It's not just points, so it's going to be a little bit different. Okay, I'm still trying to find what the y is when f of x equals what. So I'm going to find where x is 3, what is the y value? So let's come over here to the graph where here's where x is 3. Let's trace it up until we find, and we're on the graph, which is right here. Now, what is the y value at this point? If I trace it over, I see that the y value at this point on the graph is also 3. Now, The next part is talking about the domain, just like it did on the last question, but if you'll notice, the last question was just a series of points, which means the domain was just the x coordinates of those points. Well, if you look at this graph, it's a continuous function here, which means the x values are all of these and all of these, and these arrows at the end mean, even though we can't see it because the graph just stops on the picture here, but these arrows mean this graph is going to forever and ever go up and out both ways, which means eventually it's going to cover the whole entire x-axis. It's not ever going to stop. It's going to continually go from here all the way to the right forever, and here all the way to the left forever, which means it's not in between anything. It's not greater than or less than anything. The domain is all real numbers. It's going to continually go forever all the way to the left side of the x-axis and the right side of the x-axis. All right, so now for what x values is f of x equals 2. So remember, f of x is the same thing as saying y equals 2. So let's come over here to the graph and find where y equals 2, which is right here. Now, I need to go over and see, okay, so it's going to be this point. That's where y is 2. And here's another point where y is 2. So it's those 2 points on the graph. I just need to name each of those points x coordinate. So this one, if I trace it down to find its x coordinate, it'll be 4. This one, if I trace it down to find its x coordinate, it would be that 8. So 4 and 8. Now, the last part of this question says, what is the range? So the range is going to be a little bit different than the domain, because to see how the domain talks about how far left and right the graph covers, well, the range talks about how far, since it's talking about the y values, it's talking about how far up and down does this graph go. Well, if I'll note, it starts right here and then goes up forever. But it's not ever going to go below this y value. So, because the graph doesn't ever turn around and come down below to cover any of the graph down, any of this down here. So, let's see. What is the y value at this point? Well, if you trace it over, it's y value, because range has to be y, not the x. The 6 is its x value, but it's lined up with the 0 on the y. So what I want to say is that the range covers everything in the y part from 0 and up forever. So it's everything greater than or equal to 0. So that's what I need to come down here and show. So this is just great. This is less than or equal to. Well, it's not below. That's greater than. I want to be greater than or equal to 0, because it actually does touch the 0 here. I want to show that it touches 0. Okay, so that's why I'm going to come down here to the y is greater than or equal to 0. Okay, before we get to the next problems, let's talk about finding the domain of a function. When you're finding the domain of a function, you're actually looking for what the x cannot be, or is there any restrictions on the x? So for a lot of functions, it's going to be x is a real number or all real numbers, because a lot of functions don't have any restrictions. Okay, for this particular section, we are looking for restrictions on rational functions. These are functions that have the variable in the denominator. For instance, a function that looks like this. Okay, the reason that this would have a restriction or a number that x cannot be is because the denominator of a fraction cannot be 0. If the denominator of a fraction is 0, then the fraction would be considered undefined, right? You can't have 3 over 0. 0 in a denominator is undefined. So what you want to do, if there's an x in your denominator, just say, okay, x minus 2 cannot equal 0, because if x minus 2 equals 0 for this particular function, then I would have a restriction in my denominator. So set your denominator up to where it can't equal 0, and then just solve it for the x. So to get rid of the minus 2, I just added 2 to both sides. So this showed me x cannot equal 2. So let's look at some of these problems. On number 3, find the domain of this function. So if you'll notice, it's a rational function because it's got an x in its denominator. So we don't want the denominator to equal 0, which means the denominator is x minus 6. So we need to make sure x minus 6 does not equal 0. So that's exactly what you set up. You just set it up where it can't equal 0 and then solve it for x. So on this one, I would add the 6 to both sides to show that x cannot equal 6. So it can be any other real number. So x is a real number and it cannot equal 6. Now, look at number 4. Look at this. This is not a rational function. This is what's called a linear function. If I graphed this, it would just be a straight line. There is nothing in the real number line that you could not plug in for this x, okay? The last one had a restriction only because you don't want the denominator to equal 0. Well, this doesn't have a denominator. So if you just have a regular linear function, your domain will just be x is a real number. Same thing on number 5. Again, it's just x squared plus 10. There's nothing I wouldn't be able to plug in for this x because no matter what I plug in, I can square it. That's not going to give me any kind of restriction. So again, x is a real number. Now, once again, on number 6, I do have a situation where I've got a rational function with an x in the denominator. This is what gives me that restriction. So I need to make sure that 6 minus 5x does not equal 0. So that's what I set up. Solve it for x, so subtract the 6. So I still have negative 5x, which cannot equal, now over here I have negative 6. And then divide by negative 5. So x, in this case, cannot equal, here we have a negative over a negative, which just makes this turn into a positive 6/5, which means x is a real number, but x cannot equal 6/5. And then the last one, number 7, find the domain of this. It's an absolute value. It doesn't matter what I plug in for this x. I can take the absolute value of any real number, which means the domain can be any real number. Oh, here's the last one. X cubed minus 10. Again, think about where you would be replacing the x, right here. Well, there's not a real number that I can't cube or multiply times itself 3 times. I can do that to any real number. I can just multiply it times itself 3 times and be fine. So again, this right here does not create any restrictions, so it's all real numbers.